Hi, welcome to Physical Science 4.1 on electrical circuits. So first we need to talk about contact points. Absolutely every electronic device has two contact points. Generally, they're going to be a positive and a negative. Then we're going to talk about electron flow. Electron flows in two different ways. You have electron current, which is what we will talk about in this class, that goes from the negative end of a battery through whatever device you're looking at to the positive end of the battery. The other flow is called conventional flow, and it goes the opposite direction, positive to negative. But in this class, again, we will do everything negative to positive. These are the circuit elements that you need to be able to draw and identify. A resistor is a jagged line, wire is a straight line, a battery has a long and a short. Wires that are connected will actually cross, whereas wires that are not connected, you have to draw a little bubble in them. And then you need a closed switch and an open switch. So be sure you can draw those circuit elements. All right, connecting a circuit diagram. And you're going to actually be drawing circuit diagrams and taking pictures of actual circuits. So a circuit diagram, notice it has the elements that you included and straight lines. But the problem is you don't necessarily know where the wires are because some of your appliances or your circuit elements are going to have wires attached. So you may not need extra wire. So conductors and insulators, what makes something a good conductor or an insulator? And the answer is how tightly atoms are packed together. Metals are good conductors because their atoms are very tight together, but they have loose electrons. Whereas things like glass, rubber, and plastic are poor conductors, they're called insulators because their electrons don't move easily. Resistance and conductivity are inverse terms. High conductivity means low resistance, and vice versa. Resistance is a measure of how well a material resists the flow of current. In a metal, electrons are held loosely. That means the electron current can go through them easily. As the electrons run around and bump into each other, they vibrate the host atoms and collisions of these electrons where they don't go anywhere because essentially they just bounce and push the next thing forward. When a voltage is applied to a resistor, the positive side of the resistor attracts the electrons. The collisions produce that internal friction or drag, which is then resistance. A resistor is a device that resists the flow of current, and everything that you use will at some point resist the flow of current. Resistance, remember, is the ease with which electrons flow. So a resistor is determined by its resistance. The value of the resistance is a property of the resistor and depends on the length and the diameter of the resistor as well as the material it's made of. Resistors are made of conducting or semiconducting materials. Their resistance can be controlled by providing to provide a desired value. Examples of resistors are things like light bulbs and heating coils, anything that you would put into electric circuits. Resistors often have their value printed on them, and it's a color coding. Good electrical conductors have low resistance. The best electrical conductor is silver, but that's really expensive. So we'll use the second best in our homes, which is copper and aluminum. Resistance is determined by size and material. The resistance of a wire determines how much current it can carry. If the resistance is large, it will heat up too much and can cause fires. So you have two kinds of circuits. A series circuit is like having one ladder, that would be your battery, and one slide, that's your light bulb. That's a simple series circuit. And you can see on the top right, that's a circuit drawing where you actually draw the elements, but underneath that is the matching circuit diagram. So if you were to put two bulbs into a series circuit, the ladder would have two sections. You still have one power source, two resistors. You could have two resistors that are not the same size, but again, one ladder, two sections of the slide. And you could even put 3 or 4 or more resistors or light bulbs into the circuit, and they're not all going to react the same way because some resistors have more resistance than others. The second kind is a parallel circuit. And a parallel circuit, think of a parallel circuit as having more than one path, like the lake going around an island in the middle of the river. It's like a ladder with two parts to the slide, two separate slides, because the electricity has more than one path it can follow. Notice here is the junction where both light bulb 1 and light bulb 2 are attached to the battery separately, not together. Same thing, you could have more than one bulb that has different resistance. Multimeters. We're going to be using these X-Tech multimeters, and you need to know how to connect them. We're actually going to practice with them. So, to measure voltage, the circuit must be connected in order to measure voltage, and you measure it from one point to another. Black is negative, red is positive when you attach it to the circuit. But on the multimeter itself, the dial gets turned to 20V. The red probe goes into the V ohm milliamp. The black goes into the COM. And then you will touch the probe ends to either side of the battery or sections of the circuit. To measure resistance, you turn the dial to 200 ohm. The red cord stays in the V ohm amp, and the black cord goes into the COM. That's your ground wire. You will then touch this to either side of the resistor, but notice there is no battery attached. You're not doing this to a circuit that is on. Finally, to measure the current, you turn the dial to 10A, you plug the red probe into the 10A, and the black probe into the COM. You touch both probes to either side of the resistor and the battery, but here the multimeter needs to become part of the circuit, so there needs to be a gap in the circuit. We're going to be answering questions on this today and then actually doing some physical activities in the next couple days. Thanks for watching.